Hey friends, today we're talking about one-step inequalities with multiplication and division. So, if I multiply both sides of this equation by 1, nothing's going to happen, right? If I multiply it by 2, then they just double and it remains a true statement. The issue comes in when I multiply by something other than a positive. Same thing with division. If I divide by 2, it's still a true statement. -6 is still less than -5, because remember, we would rather be in a debt of 5. But again, when I divide by a negative, that's where an issue comes in. So take a look. If I divide or multiply by a negative, for example, multiplying by -2, over here I get -6, and over here I get +6. Is this now a true statement? No, because -6 is not greater than 6. So, when you multiply or divide by a negative, you're changing the sign, which means you also have to change your inequality sign. It's not going to remain a true statement. Same over here. If we would divide by a -2, my signs are going to change, and now I have 6 is less than 5. We know that's not a true statement. So, we have to, again, flip our signs of our inequality. Okay, so take a moment and write this down. When multiplying or dividing by a negative, not only does the numbers signs change, but the inequalities sign changes as well. So you've got your numbers changing, and then your inequality has to flip, okay? Make sure that you have this written down in your notebook. All right, so let's look at some examples. In number 1, we're dividing by a positive to solve. So, does my sign change? No. This remains a true statement. So, x is less than or equal to 5. We're going to plot this on our number line, and again, you don't need very many numbers. You can just do 2 or 3 on each side, even 1 I'm okay with. And then this is going to be a solid dot at 5. And it means that x is less than 5, so any number that's less than 5, including 5. On this one, we're dividing by a -2. So this is going to change our sign, and it's going to change our inequality sign. So g is now greater than -5. So we have -5 on this side, -4, and -6. G is going to be greater than, so open dot, because it's not equal to, and it's any number greater than 5. So if we wanted to interpret this, our number can be 5 or any number less than 5. Over here, it cannot be -5, but it can be any number greater than -5, including -4.9 repeating all the way to our positives. All right, I've got a couple for you to try. Go ahead and try these, and I'll be back in just a second to show you what I did. Okay, so grab your red pen. Here's my work. On this one, you're dividing by a -4, so the signs change. This side is now positive, this side is now negative, and this sign also needs to change. So when we plot it, we have a solid dot at -10, and it can be any number greater. So it can be -10 or any number greater than -10, including all the decimals in between these two numbers. It doesn't start at -9. It can be -9 with the 9 repeating. And on to the positives. Over here, we're going to divide by a 3, and we're not dividing by a negative, so our sign stays. So when we plot it, okay, so you're going to have any number that's less than 3, not including 3. So open dot, and it goes to the left. So x can be any number less than 3, including the decimal 2.9 repeating, and anything smaller than that. So don't forget your decimals in between here. It doesn't start at 2. Let's look at some division. If we're dividing x by 7, how do we undo that? Well, we multiply by 7 on both sides. When we do so, x is less than or equal to 42. So when we plot it, we have a closed dot because our x can be 42 and it can be anything less than 42. So our arrow is going to go to the left. Notice that our signs didn't change, so we don't need to change this sign. However, over here, we're going to have to multiply by a -3 on both sides. So we get x is going to be greater than or equal to -12 because now we have to, all of our signs change, so our inequality sign changes as well. Again, we have a solid dot because it's equal to, but x this time is anything greater. So it can be anything from -12 and on. So over here, it's -12 all the way to the positives. Okay, go ahead and try these, and I'll be back in just a second to show you what I did. Make sure that you also interpret them for me. I want to see what x actually means written out in words. Okay? I'll be back in just a second to show you what I did. All right, so here's my work. You should have multiplied by 2 on both sides and gotten x is less than or equal to 8. Because you didn't have to multiply by a negative, it stays the same inequality sign, and x is less than or equal to, so it's a solid dot. So x can be 8 or any number less than 8. Over here on number 6, we're multiplying by a -2. So that's going to change our sign, and instead of x being a less than, now he's greater than 9. So we have an open dot because he can't be 9, but he can be anything greater. So x is any number greater than 9, but not 9. Let's look at some real-world examples now. Ling is working at the zoo, and she's making $8 an hour. We want to write and solve an inequality that can be used to find out how many hours she must work in a week to earn at least $120. So she can earn $120, so that's equal to, and she can earn anything greater than $120. So we want our answer of x to be greater than or equal to $120. So we can figure out by putting the 8 in front of our x that 8 times the number of hours needs to be greater than or equal to $120. So there's our inequality. Now we're going to divide by 8 on both sides, and we get x is greater than or equal to 15 hours. So let's write a conclusion statement. Ling must work at least 15 hours to make $120. We could also write she must work 15 or more hours to make $120. Okay, here's one for you to try. Each game at a carnival costs 50 cents, or you can pay $15 and play an unlimited amount of games. Write and solve an inequality to find out how many times you should play a game so that the unlimited gameplay is less expensive than paying for each time. What does the solution mean? Go ahead and try it, and I'll be back in just a second to show you what I did. Okay, so here's some key pieces of information. Each game is going to cost you 50 cents, so 50 cents per game. You know that you don't want to exceed the $15 amount, so this number needs to be less than this 15. You can pay that, so you can also be equal to. But here's where that changes. It says that it needs to be less expensive. So do we want it to equal 15? No. So that's why it remains just a less than sign and not an equal to. So now we can divide both sides of our inequality by 50 cents, and we know that we can play up to 30 games in order for it to be a better deal. So you can play less than 30 games, no more than 30 games, or at most 30 games. And that's all I have. See you next time.